Today on Capechi's Corner, we're going to look at the topic of functions. Now, what is a function? A function is a relationship between an input and an output. Input is usually the x and the output is the y, or different variables if that's what you're using. In a function, there is exactly one output for each input. The relation shown is a function because each element of the domain is paired with exactly one element in the range. So a lot of times what we say is for every input, there is exactly one output, just one. Okay, so we're going to explore this a little bit. Here are some representations of some functions. So in this first one, the table, each of these x values only appear once. So that's a function. When looking at mapping, this -2 is only listed once, and it's only going, there's only one arrow going from -2 to 1. 0 goes to -1 and 2 goes to 1. So it's okay that the range has 2 arrows going to it. We just can't have 2 arrows coming from my domain. Okay, here's a parabola that we've seen, a quadratic. That's a function. And the graph here, we'll talk about the vertical line test. That's also a function. Okay, so the vertical line test, if a vertical line intersects a graph more than once, then the graph is not a function. Otherwise, it is a function. So what this means is if I draw a vertical line through all different parts of the graph, if it only hits the graph one time, then yes, it's a function. Looking at the second example, if I draw my vertical line there, it only hits it once, but I can do it somewhere else and then it hits the graph twice, so that way it's not a function. And looking at the last example here would only hit the graph once. Now the question we have is right here. Because this is an open circle and this is a closed circle, it technically only hits that spot one time where it's closed. So it is a function. If they both happen to be closed and there was like an overlapping at that x value, then that would not be a function. Okay, when we're looking at function notation, a lot of times we just take the y is equal to, and we just change that y to an f of x. That's how you say that, f of x. Okay, and the x represents the element of the domain or the input, right? That's your x value. And the f of x is the y or your output, the range. All right, let's explore a little bit more. So here is, we're going to identify some function. Which of these are functions? So in this first one, each domain is only has one arrow going for it. So that would mean that yes, that's a function. That one's good. And looking at the table, when we're looking at our domains, we notice that the x value, the number 0 is repeated. So that would be no, that it's not a function, because for every input, we can only have exactly one output. And in this case, we have two outputs, 8 and -1. So that's a no. In our next example of just the ordered pairs, if I just look, I like to underline my x value so that it kind of helps me visually. You can see that this -2 is listed twice in my x value. Again, we're not concerned about the y value, just the x value. So that's a no. So my answer is here, letter A, just that first one only. Okay, let's look at a word problem with this. It says 5 schools are competing in the long jump portion of a track meet. The distance of the players with the best jump on each team are as follows, and they list them. So team number 1, if you go up here, you see it has the best jump was 20.6. And I kind of filled it in to save some time for the video. So when you're looking at that, when we list our domains, whenever you list your domain or your range, you'll always list it from lowest number to highest number. So the domains here, this is our x value here. So it's just 1, 2, 3, 4, 5. That was easy. That was in order. The range, which is either considered my f of x or my y, either one, again, is listed from lowest value to highest value. So I took all these, and 19.4 was the lowest value, and I kept going and I listed all of my ranges. Now the question is, determine if this is a function or not. So we have to see our x values here it's only one per team, right? So we're going to say yes, it is a function because each x, right, each x value is only paired with one y. We could say for every input, there's only one output. Okay, let's do a little bit more with the vertical line test. Okay, let's practice some. So here, if I put my vertical lines through there, it's only ever hitting each graph once. So that's a function. Let's look at our next example again. If I hit it in a lot of different spots, it's hitting in more than one spot. So this one is not a function. Okay, continue on now. We just have points. So again, I just want to see if more than one point is lined up. If I do my vertical line test, which it's not. So that one's okay. This is a function. So when would those points not be a function? So an example of that would be if I had a point here, just say I had a point there, and then I did my vertical line test, that would hit 2 points. That would make that not a function. But given what we have, that's a function. That's good to go. Now with this last one, it's a vertical line, but if I draw a vertical line right on top of it, it actually would hit infinitely number of times. So that would be not a function. Okay. All right, so we're moving on to the next part of our lesson in which we're going to substitute some values in for function. So this is function form right there, and it says to find each value. So we say this f of -4. That's how we say that. And what that means is everywhere you see an x, you're going to substitute a -4, and you're looking for a value or a number. So again, to make things a little quicker, I started things off and I substituted in already. So -3 times -4 gives me +12 plus my 2. So the correct notation is going to be f of -4 is equal to 14 because that's what 12 plus 2 is. Okay, let's look at another example. F of 5. Now this is f of 5 plus 8, not f of 8, just the number 8. So first we're going to find f of 5. So it's -15 plus 2. So f of 5 is equal to -13. And now we're going to substitute that in. So I have f of 5 plus 8. That's what the question's asking. Is equal to -13 plus that 8, which has a value of -5. So again, when I add those, that's what I get. So my notation is f of 5 plus 8 is equal to -5. Okay, moving on. This time we're asked to find two functions with different values, and then we're going to have to subtract them. So let's get started. So that gives me -9 plus 2. So I have f of 3 is equal to -7, and I'll come back to that in just a minute. F of 6 is equal to -18 plus 2, which equals -16. So if I do f of 3 minus f of 6, I get -7 minus -16. So that's going to end up being -7 plus 16, -7 plus 16. So I'm going to have f of 3 minus f of 6 is equal to +9. Okay? All right, let's keep going. So again, this time we have an h of x. It's the same thing except for now we have an x squared. So we do have to just be careful there. So again, I've set it up to save some time. So this gives me -6. This is h of 2. So I'm going to substitute a 2 everywhere where I see an x. That gives me 2 squared is 4. 18 times 6 is 36 plus 36. So this gives me -24 plus 36 plus 36. So I know h of 2 is equal to 48. Okay, and letter B, we have h of 4 minus h of 1, kind of like we did above. So substitute it in. I get -6. 4 squared is 16, plus 18 times 4 gives me 72, plus 36. I can do that all on my calculator. So h of 4, once I do all those values, h of 4 is equal to 12. Now I'll do h of 1. So I get -6 times 1 squared is 1, plus 18 times 1 is 18, plus 36. Again, I can just use my calculator now. So at this point, h of 1 is equal to 48. Okay, so my final answer there is h of 4 minus h of 1 is equal to 12 minus 48. So h of 4 minus h of 1 is equal to negative 36. Okay, let's take a look at a word problem here. Kind of taking the same idea. It says Mason works at the movie theater after school. The function g of x is equal to 9.25 represents the amount of money he makes before taxes for each hour that he works. Evaluate and interpret the function for each value. Well, let's take a look at this. So the constant there, what's going to be the rate of change? The rate of change is going to be how much he makes per hour, right? That's the slope, right? 9.25. That's how much he makes per hour. The x is how many hours he works. Obviously, the more hours he works, the more money he's going to make. So let's see how we do. So g of 8 is equal to 9.25 times 8. So when I multiply that, I get 74. So what does that mean? It says if Mason works 8 hours, we just found out that that's 74. He will make $74. Okay, let's look at another value. G of 14, remember 14 is the number of hours of work. So if I substitute that into my function, I get $129.50. So if he works 14 hours, that's how much he will make, $129.50. Okay, looking at our last word problem, it says a swimming pool that holds 10,000 gallons of water is being filled at a rate of 600 gallons per hour. So for every hour that goes by, it has 600 more gallons of water. Here's the function, which represents the amount of water in the pool after X hours. So we know X is the number of hours. So it says find H of 3.25. So that's the number of hours. We're going to substitute that into our function and we get 1,950 gallons. Okay, what does that mean? It says describe the meaning of that. So after 3.25, right, that's our X values, there is 1,950 gallons of water in the pool. Okay, thanks so much for stopping by today. You have a great day.